Yes, welcome back again. So in the earlier session, we have seen what are the different types of riveted joints and what is the purpose of using the rivets, different types of rivets based upon its terminology we have seen in the earlier sessions, right? So in this particular session, we are going to see some important problems which are related to the riveted joints. Hope this class may be interesting. So here we are going to see about the problems on riveted joints. Okay. So if you consider a problem which is related upon a plate having 100 mm diameter and with 100 mm wide and 10 mm thickness, which is required to be welded together to another plate by the means of double parallel fillets, where the condition is the plates are subjected to static loading condition of KT kilonewtons. Next, here what we have to find. The length of the weld is permissible shear stress. The weld does not exceed 55 megapascals. So this is the condition that it is being given. So how we are going to solve? So as the given data with thickness, load, we have calculated the things that have been given. Now here you have to know the size, plate plate thickness. So we have to know we have known these things. So here we are calculating the maximum load of the plate of the double parallel fillet weld P is equal to 80 into 103. So we are getting the value, and therefore by adding 12.5 mm for starting and stopping of the weld run, we can able to get I is equal to 103 plus 12.5 is equal to 115.5 mm. So like this we can able to solve. And the second case, second condition, second problem you can see a plate having 100 mm wide and 12.5 mm thickness is to be welded to another plate by the means of fillet weld. Okay, the plates are subjected to load of 50 kilonewtons. Okay, find now what we have to find. Find the length of the weld so that the maximum shear stress does not exceed 56 megapascals. So you have to consider some conditions like it is under the fatigue loading conditions. So the given data is width is equal to thickness is equal to load is equal to. Okay. From this what how we are going to calculate. Okay. So here you can see the length of the weld and size of the weld plate thickness is equal to 12.5 mm it is given. And here the maximum loading condition of the plates which are to be carried out for the double parallel fillet welds are L is equal to 50 into 103 by 990 is equal to, we are getting the value by adding the 12.5 mm for the starting and stopping of the weld run while we are starting the welding operations. So L is equal to 50.5 plus 12.5 is equal to 63 mm. Next, length of the weld for fatigue loading condition. So see from the table we can find the stress concentration factor from parallel fillet welding operations. So the permissible shear or allowable shear stress is torque tau is equal to the value we have got is 20.74. So from we already know that the maximum load for the plates carry the double parallel plate weld is 50 into 103. So the value of L we are getting after solving these terms at 136.2 mm, right? So for that we are adding 12.5 for starting and stopping of the weld run. So the L value is being 136.52 plus 12.5, we are getting 148.57 mm. So like this, we can able to calculate. Next, another problem we are going to see a plate having 75 mm wide. So this you can able to solve this problem. So just we'll discuss. A plate of 75 mm wide and 12.5 mm thick is joined together by another plate of a single transverse weld. Okay, keep that in mind. And double parallel fillet weld as shown in the figure. See, the maximum tensile and shear stresses are given as 70 megapascals and 56 megapascals respectively. Okay, tensile and shear stresses. It is indicating tensile and it is indicating the shear. Find here what you have to find is the length of each plate parallel fillet weld, and if the joint is subjected to both the condition, whether it may be a static or fatigue loading condition. So here you have to calculate. First thing is you have to analyze the figure and then how we are going to solve. So from the given data, we can able to take down some of the points like thickness, width, tensile stress, and torque tau is equal to 56 megapascals. The effective welding area is represented by subtracting this value from this, and therefore we get L1 is equal to 62.5 mm. Next, length of each parallel fillet static loading. L2 we would like to calculate. L2 is nothing but length of each parallel fillet. Okay, so where load is equal, P is equal to area into stress. Yeah, this value you have got 175 to 12.5 into 70, we are getting 60. This value. Next, how much of load that is carried out by single transverse weld, where P1 is equal to, by solving it, we are getting this value. Next, the total load carried away by the double parallel fillet weld P2, P1 and P2 we have to calculate. P2, if you are calculating, we are getting the value of 990 L2. And next, load carried by the joint P. So by adding up these values, we are getting 27.2 mm. Okay. Next, length of each parallel fatigue loading. So see here we have got the permissible tensile stress as sigma T is equal to 70 by 1.5. So the value is 46.7 Newton per mm square. And the permissible shear stress torque tau is equal to 56 by 2.7. So the value is obtained is 20.74 Newton per mm square. Next, load carried by single transverse weld, which represents P1. So by calculating this, all the things we're getting the value of 25,795 newtons. Okay, and the load carried by the double fillet weld P2. By inserting all these values, we're getting the value of 366 L2N. Load carried by the joint P. So by adding these to P1 plus P2, we are getting the value of 108.8 mm. So for that, for weld, so another factor we have to add. What means starting and stopping of the weld run is default 12.5 mm. So for this value, we are adding this one. We are getting the L2 as 121.3 mm. Okay. Likewise, we are going to solve this problem. So similar problems we can able to try, and we can able to get the results. So these are the next concept we are going to see the problems in the riveted joints, right? Hope you have understood. Thank you. Have a nice day.